This video was brought to you by GeneralPack.com, making power systems intuitive, open, and free to everyone, everywhere. Consider subscribing and supporting through patreon.com/generalpack. This is the mechanism for you to support us financially so we can continue making high-quality power system video tutorials. Our corporate sponsor for this topic is AllumiaX.com from Seattle, Washington. Contact them for industrial and commercial power system studies. Types of protective relays and design requirements, Part 2C. This is the third part of Topic 2 in the series of types of relays. In this part, we will be discussing distance or impedance relays and reverse power relays. So the first one, distance protection impedance relays. These distance protection relays are those in which the operation is governed by a ratio, right, of applied voltage and current, and therefore to impedance or a component of impedance in the protective circuit. So we're looking at both current and voltage, and we're calculating an impedance value, and that's used to protect the circuit. According to the IEEE Buff book, distance relays may have the following features. It has the ability to detect faults within a preset distance along a transmission line from its location. A distance relay therefore looks at current and voltage and compares these two quantities on the basis of Ohm's law. Now moving on to the working mechanism of these relays, here we consider that the impedance relay is placed on a transmission line for the protection of the line AB. Z is the impedance of the line in normal operating condition. If the impedance of the line falls below the normal impedance set point Z, then the relay starts working. Let's suppose the fault F1 occurs in the line AB. The fault sensed by the relay has a lower impedance compared to the line impedance and therefore falls below the relay set point. The fault impedance is ZF. The relay starts operating and it sends a tripping command to the circuit breaker. If the fault reaches beyond the protective zone, the contacts of the relay remain unclosed. The voltage and the current operating element are the two most important components of an impedance relay. The deflecting torque is produced by a secondary current of CT, and restoring torque is produced by the voltage of the potential transformer. In normal operating conditions, restoring torque is greater than the deflecting torque, right? And because of that, relays will not operate. But in a faulty condition, the current becomes quite large, whereas the voltage becomes less. Consequently, deflecting torque becomes more than the restoring torque, and the dynamic parts of the relay starts moving, which ultimately closes the normal open contacts of the relay. Now let's have a look at their applications. Distance relays are widely used for protection of transmission lines by measuring the impedance between the fault location and the protective relay. These relays provide primary or backup protection for AC transmission lines and distribution lines against three-phase faults, phase-to-phase fault, and phase-to-ground faults for a very special type of impedance relay. The next type of relay is called a reverse power relay. Now, according to the IEEE Buff book, the reverse power relay is sensitive, high-speed, and directional protective relay that can be used to detect line-to-ground faults on a delta side of the transformer bank by detecting the in-phase components of the transformer magnetizing current and prevents power from flowing in the reverse direction. What that means is that it prevents power from flowing in the reverse direction, right? And this occurs when another relay in the system trips the transformer primary breaker and the breaker is energized through this secondary circuit. Now, in applying this relay, the relay operations should be delayed to prevent undesirable operations resulting from a generator swings relative to the utility. The relay only needs to be fast enough to permit successful reclosure from the remote end. And what we're saying here is that we can't make it so fast that so that nuisance tripping would occur in the system. So we need to have a delay in the reverse power relay to avoid nuisance tripping and to detect current in the reverse direction. Now, moving on, the working mechanism of this type of relay. Typically, this relay is used to monitor power from a generator, and in case the generator output falls below a preset value, it quickly disconnects the generator to avoid power from flowing into the stator coil. The generator output can fail due to the problems of the primary mover, the turbine, or the engine that drives the generator, or issue with the speed controller. When the primary mover fails, the generator stops producing power and instead start drawing power from the other parallel sources and start motor because of it. The reverse power relay senses any reverse direction of power flow and disconnects the generator to avoid any possible damage. Looking at its applications, reverse power flow relays may be used where secondary generators of the facility are operating in sync with the large utility grid. Such that the utility supply fails, the reverse power flow relay prevents the power from the generators from flowing into the grid by quickly disconnecting the point of common coupling. So this is to prevent backfeeding into the utility grid. Another application is that the relay is used in facilities where generators run in parallel with the utility or another generator so as to prevent power from the bus bar or other active generator from flowing towards the inactive generator when the output fails. That is all for this part. Now in the next video, we will be discussing the next two different types of relays that are the differential relays and the time delay relays used in electrical power systems and their applications as well. Now we hope that you have a continued interest in this topic and series and either as a student or professional. And we hope you find this content useful and enlightening. Please subscribe to General Pack or become our patron at patreon.com/generalpack. GeneralPack.com, making power systems intuitive, open, and free to everyone, everywhere. Thank you.